Okay, in this class we will discuss about uh, some problems in operational amplifier. So let us consider the first problem. The first problem. A differential amplifier. A differential amplifier has differential mode gain. I will just put it as in short form. So that is a this is differential mode gain. Okay, differential mode gain equal to a diff equal to 100 and common mode gain. Common mode I will denote it as ACM. So a common mode gain is equal to 0.01. Then what will be the CMRR? What will be CMRR in dB? So this is a question. A differential amplifier has differential mode gain of 100 and common mode gain of 0.01. What will be the CMRR in dB? Okay, so CMRR in dB, as you know, CMRR in dB, you can write this as 20 log CMRR, okay, 20 log of CMRR, and this CMRR, equation for CMRR is equal to A differential, that is differential mode gain divided by common mode gain, and this value from for the given problem, this value will be 100 divided by 0.01 and it is equal to 10 raised to 4. Okay, 10 raised to 4, 10,000. So that is CMRR. So CMRR in dB, CMRR in dB will become, this is 20 log of 10 raised to 4. So this is base of 10. So directly you can write this as 20 into 4. This is equal to 80. 80 dB. So this is how we will calculate the common mode rejection ratio, that is CMRR of an op amp. Okay. So next question. Let's discuss the next question. So in the given circuit, what is the output voltage? That is question, and the circuit is like this. Just draw that. This is minus plus terminal. That is inverting and non-inverting terminal. The resistor here side is grounded, and we have a feedback resistor. And the signal is given to this non-inverting terminal, and then it is grounded. And this is 120 microvolt, and this is 24 kilo ohm, and here we have 240 kilo ohm resistors. The question is, what will be the output voltage of this circuit? V out is, how much is the V out? Okay. So first thing you have to understand is the configuration of the given circuit. So as you can see from here, the signal is applied to the positive terminal of the op amp, and feedback is, as you know, this feedback is from the negative terminal of the op amp. Okay. So this is a negative feedback circuit, and the signal is given to positive terminal. So positive terminal, if you have given signal to the positive terminal, then the configuration will be a non-inverting configuration and with a negative feedback. Okay, so the configuration is non-inverting negative feedback configuration. Okay, so for non-inverting configuration, as you know, for non-inverting configuration, we have the gain equal to, directly you can write gain equal to 1 plus feedback resistor by input resistor, that is, or serial resistor, that is R1. Here RF is this one and R1 is this one. Okay, so that is the equation. For non-inverting configuration. In the same way, if you are having an inverting configuration, which means your signal is applied to the negative terminal or inverting terminal of the op-amp, which is like this. If you are having this op-amp and minus and plus terminal here, then if all the feedback connection and the input resistance, all those things are same. Only the difference is in that negative or inverting terminal, we will be having that signal. We are applying input signal at the inverting terminal and the positive terminal is grounded. So this is inverting configuration of it. So in this case, if your signal is applied to the negative terminal, then you have to write your gain as, your gain will be equal to, in this case again, if you consider this as R1, this is RF, then this will be minus RF divided by R for inverting configuration. Okay, okay, that's about inverting configuration. But in our problem, it is non-inverting configuration, so that the gain will be 1 plus RF by R. Now, what is gain? Gain is nothing but V out by V in. Output voltage by input voltage is the gain. So I can write V out by V in here. Okay, or we can say, or V out is equal to 1 plus RF divided by R1 into V in. Okay, and in the given problem, all these things are given. So I can directly write this as 1 plus, and RF is 240 kilo, then R1 is 24 kilo, this K will get cancelled anyway, and then that is multiplied with V in. V in is 120 microvolt. 120 microvolt, I can just write that microvolt as 10 raised to minus 6 volt. This into 10 raised to minus 6. This much of volt. Okay. Then if you calculate this, then you can directly write. You will get, if you calculate the value of this one, then you will, here 240 by 24 will come, that is 10, then 10 plus 1 is 11, 11 into 120 will come here, and if you do all those calculations, then you will get 12.12 millivolt. This is the final output of this particular configuration. So the question is what is the output of this circuit, and the output is 12.12 millivolt. So this kind of questions may come, and it is very easy to. Only the thing is that they will change the connections to make the circuit more confusing. But the procedures are same, and if you know the simplification of that circuit, then you can directly solve all these kind of problems very easily. Okay, I will give you another example where you will get some kind of complicated. It is not complicated, but you just have to know how you can deal with such situation. Okay, so I will just go for another problem. number 3. So let us consider another circuit. The equations are same, but by looking at the circuit, it may be looking like a little bit complicated circuit, but it is not. Okay, it is very easy, and we have to do the same procedure in this case also. Only that circuit is a little bit modified in this case. Just yeah. This is your op-amp, and this is your inverting terminal, and this one is non-inverting terminal, and we are applying voltage or input voltage to both terminal, plus 2 and plus 1 here, and we have a feedback network. Also we are having another network here. Or first we will deal with the simplest one, simple one, and then we'll do the other so that you can understand this more clearly. So let us consider this case, and we have a resistors 1 kilo ohm here and 1 kilo ohm here, and 5 kilo ohm here. So this is the configuration, or this is a circuit. As you can directly see, the feedback is given from negative terminal, so it is a inverting configuration. Sorry, it is negative feedback circuit, and as also you can see here. You can see this. Here you can see this is plus 1 volt and this is plus 2 volt. Both inputs are given at the same time. Okay, both inputs are given at the same time. We are having plus 2 volt at the inverting terminal and plus 1 volt at the non-inverting terminal. Now how we will do this? Here first we have to apply the superposition principle, which means when you are having two inputs in your circuit, then you can and if you want to calculate what is the output, then you can use the superposition principle, and the superposition principle says that if you are having multiple number of inputs, more than one input in your circuit, then you calculate what is the output of the circuit for each individual input, then you add all those outputs to get the final output. Okay, so in this case you are having two inputs, one is plus 1 and another one is plus 2. So first you consider any one of the input and calculate what is the output corresponding to that particular case. Then you consider the next input, then calculate what is the output of that particular case. Then you add both of this, then you will get the final answer, the final output. Okay, that is called a superposition principle. So by superposition principle, first you have to get what is V out. V out. Let's say V out. We can say this is V out plus, or you can denote it with anything. I will just do it. So V out plus means when you are having the input at the non-inverting terminal only. Okay, so that is plus 1 only present, plus 2 is grounded. This inverting terminal is grounded. So in that case, what will be the output? The gain, so which means that your input is only at the non-inverting terminal. Okay, so the gain is 1 plus Rf divided by R1. Okay, and the output voltage will be this gain times input voltage, V. Okay, and that will be equal to 1 plus Rf by R1. Rf is 1, sorry, Rf is 5 in this case, and R1 is 1. R1 is 1. So this is your R1 now. Okay, so that is then you will get 1 plus 5 divided by 1, 5 divided by 1 into V. V is 1 volt. 1 volt. Now you just calculate what is this. So you'll get 1 plus 5, 6. Okay, 6 into 1 volt, and that is 6 volt. So this is 6 volt. This is when you are considering only one input, that is to the non-inverting terminal. Now you consider the second input, that is going to the inverting terminal. So I will just calculate what is the output of that case, or output when only we are having the input at inverting terminal. So I will just write it as V out, V or minus, and this is equal to, as you know, the gain for inverting configuration is minus RF by R1. So the output voltage will be minus RF by R1 into input voltage, and this is equal to minus RF is 5 kilo ohm, R1 is, so this is 5 minus 5 divided by 1 into V in is 2. Okay, the potential applied to the inverting terminal, and this is obviously this is minus 10. Now what is the total output? Total output is V out is equal to, total output is V out, this is equal to V O plus VO minus, VO plus VO minus, and this is equal to 6 volt plus minus 10 volt, and that will be equal to minus 4 volt. So this is the total output. This is how we will apply superposition principle. Okay. So when you are having two inputs, then you just have to take the total output like this. And if you are having n number of such inputs, then you can also use the superposition principle and apply that same in this case and calculate what is your. It is simple. Okay. Now we will modify the circuit a little bit, slightly. I will just use the same circuit. Okay. I will just erase all these values. Now I will be using the same circuit, and I will just modify this with one more resistor. I will just put one more resistor in this side, and this side is grounded. Now we just have to calculate what is the output in this case, and I will just this is also 1 kilo ohm. Now what will be the output? Okay, so for this case also we have to consider the same scenario. So the total output will be V out plus V out minus, there is no change. Okay, or I will just rewrite that in V out minus plus V out plus. Okay, so just for convenience, so V out minus plus V out plus, which means when you are having only that voltage at the inverting terminal plus the output corresponding to the case when you are having only the input at non-inverting terminal. So both of those cases, if you add both of these, then you will get the total. Now if you consider this scenario, V out minus, VO minus will not change in this case because there is no change in the circuit in the negative or inverting part. So, or you can, we will calculate both. Okay, no problem. So in this case, VO minus will be the input voltage, that is plus 2. Okay, and multiplied with the gain. Okay, multiplied with, so the minus RF divided by R1 into input voltage is 2 volt, that is for VO minus. Okay, then plus the second term is input voltage. So in this case, what will be the input voltage? Okay, this is very important. So if you, even if you are applying plus 1 volt here, but here you are having a voltage divider. Okay, you are having a resistor here, then you have a resistor here. So the voltage will be divided in this circuit, and you have to calculate what will be the potential at this point. and that potential is given to the non-inverting terminal of the op amp. Okay, let's say this point is potential at this point is VA. So this VA will be the input of op amp. This plus 1 is not the input, but VA is the input because you are using a potential divider circuit here, because you are having a resistor, additional resistor here. Now what will happen? If you are having a potential divider, how you will calculate the potential at that point VA? So if you are having a circuit like this is grounded, and here you have applied some potential V, and you are having R1, R2 resistor. So you have to calculate what is the potential at VA at this point. Okay. So to do this problem, you just have to consider the current flow through this circuit. Current flow through this circuit. And the current flow, you can directly write the current is nothing but the potential divided by the resistor. Okay. So what is potential? Potential is V. So V divided by resistance of the circuit. As you can see, this R1 and R2 are series in connection, because here you are having a plus potential, some high potential, and here it is grounded. So these two terminals, this terminal and this terminals are different, so they are not connected into same point. So these two resistors are in series connection. So total resistance of the circuit is R1 plus R2. So this is R1 plus R2, that is the total resistance of the circuit. So total potential is V volt you are applying here. Okay, that is total potential. There is no other sources. So V divided by R1 plus R2. This is the current through the circuit. Let's say this is I. So this value is I, current. And what is the potential VA? VA is the potential across this resistor R2. If you are using multimeter, you will be measuring the potential. You will be measuring potential across this resistor for the VA, potential VA, because this side is already grounded. So if you are calculating what is the potential difference between this point and this point, that will be VA. Okay? Because the potential difference is in that case will be VA minus 0 divided by or potential difference is VA minus 0. This is the VA minus this point is 0. So that is nothing but VA. So that is the potential across this resistor R2, and that potential only is given to op amp. So if this is current I, okay, V by R1 plus R2, that is the total potential in the circuit is V divided by total resistance is R1 plus R2. This is current. This current into this current is flowing through the circuit, and it will be flowing through this resistor R2. So if you multiply that current into this resistor R2, then you will get what is the potential drop across this resistor R2. Okay, so this is the equation. In the same way, you can calculate what is the potential VA in this circuit. So in this case, the potential VA will be 1 divided by 1 is the potential applied at this point. Okay, so 1 divided by R1 plus R2. R1 plus R2 is nothing but 1 plus 1 kilo ohm. Okay, 1 plus 1 kilo ohm, and that is this is current. Now this is current flowing through this circuit multiplied with the resistance 1 kilo ohm. 1 kilo ohm. That is the potential VA. That is the potential VA. That is the input potential of the non-inverting terminal, and this has to be multiplied with your gain factor, that is 1 plus RF divided by R. Okay. So this is minus RF by R1 is nothing but 5, minus 5 into 2 volt. There is no change. We already calculated this value, minus 10 in the previous exercise. And this plus 1 by 1 plus 1 is 1 by 2. 1 by 2 into 1 kilo will cancel. Okay. 1 by 2 into 1 kilo. Okay. So this is 1 by 2 into 1 k. Okay. This k will be there. Okay. This will not cancel. And into 1 plus RF by R1. What is 1 plus RF by R1? 1 plus RF by R1 is 1 plus 5 divided by 1. So that is 6. Nothing but 6. Now you just have to calculate what is the value. Okay, just you I think this one, okay, this is voltage, right? This is voltage. So this kilo and the denominator kilo will be cancelled. So I don't have to write this K here. The other one is voltage. This one is voltage. Okay. So this K and denominator we are having 1 plus 1K, okay, 2K. So that will get this kilo and kilo will get cancelled and we will get 1 by 2. Now you just calculate what this is minus 10 plus this part you will be having 1 by 2 into this is 1. So 1 by 2 into 5 by 1 is 6. 1 by 2 into 6 is 3. So this is minus 7 volt. Okay. So that is the output voltage in this case. So the difference you can see in the previous from the previous problem when you are considering one more resistor in the positive terminal or non-inverting terminal, then your output is going to change. Output will be different, and then you have to apply that potential divider method and calculate what is the potential at this point VA. That will be your input. That means the potential drop across this resistor. That will be your input to the op amp. Okay, so all the problems basics are same. Only the circuit they will modify and you have to do some more trick or some more some more you have to apply some more principles, basic principles of electronics circuits in this problems. Then you can easily calculate what is what are the values corresponding. Okay, so it is not a big deal, but you just have to know what is the basic equation. Then you have to reduce the circuit or have to apply some basic principle like Kirchhoff's law, or, the voltage divider rule, or the uh, superposition principle, and all those things. Now we'll consider another problem, which is also from the op-amp section. It is related to integrator. So if you are having a circuit like this is not a practical case, practical integrator, but a simple one. So let us consider a resistor here and capacitor as feedback. When you are having capacitor as feedback, which means it is an integrator, and you are applying potential V in here in this point. This is V in input voltage, and this terminal is grounded. This is your positive terminal or non-inverting terminal. This is negative terminal, and this is 1K resistor, and capacitor value is 1 micro. So in this case, what will be the output? In the same fashion, you can also solve for differential circuit, differentiation circuit. In that case, you will be having a resistor in the feedback section instead of capacitor, and here you will be having a capacitor. You interchange resistor and capacitor from the circuit, then you will get a differentiate. Now the question is, if you are having input voltage V in is equal to 5 sine of 1000 T. Okay, this is your input voltage V in. What will be the output voltage in this circuit? It is a simple problem. First thing that you have to understand is the given problem is an integrator, or the given circuit is an integrator. So by looking at the feedback section, what is the element in that feedback section, whether it is capacitor or resistor, you can say this is a integrator, and checking at the, you also have to check what is the component at the input section, okay, or input part, that if it is a resistor and feedback is having a capacitor, then it is definitely an integrator, okay. And in the case of practical integrator, you will be having one more additional resistor parallel to this capacitor, okay, in the feedback section. And if you consider differentiator, what will be the case? For the differentiator case, you will be having same circuit, but the difference is you will be having a capacitor here. You will be applying V in here, and your this feedback will be having a resistor. Okay. All these are ideal case or theoretical case if you are considering practical integrator and differentiator, and in the case of practical differentiator you will be having a capacitor here parallel to this resistor and a resistor here series to this capacitor. You just have to consider those things when you consider the practical differentiator and integrator. But we will do this simple circuit. Probably they will ask only this kind of questions. So in this case, what will be the output? Okay, as you know, for integrator circuit, the output voltage is V out is nothing but minus 1 by RC minus 1 by RC. R is the input resistance. Okay, this one. Minus 1 by RC times integral of input voltage V in dt. So this is the expression for calculating the output of integrator. In the same way for differentiator, you know, V out will be equal to minus RC times V dV in divided by dt. This is the output of differentiator for this circuit. Just you have to calculate what is differentiation and integration. So in this case, you have given V in input as this waveform. So if you just integrate that, then you will get minus 1 divided by RC. RC is 1 kilo ohm into 1 micro. So this is 1 into 10 raised to 3 into 1 micro is 1 into 10 raised to minus 6. Okay, 1 kilo ohm into 1 micro. Then integral of 5 V input voltage, that is 5 sine 1000 t. Sometimes they will get omega t or something like that also, no problem. So this is dt. So in the denominator we will be having 1 divided by 10 raised to minus 3, and this will get cancelled and we will get minus 3, and then 5 you can take outside, 5 into integral of sine 1000 t dt, that is, what is that, cos, integral of sine is cos 1000 t, okay, cos 1000 t. Also you have to integrate this portion you have to consider. So in that case you will get cos 1000 t, then you will be having into 1000. Now if you consider this, then you can cancel this 1000 and this 10 raised to minus 3 here. I think 1 into 10 raised to minus 3, that is not possible. Okay, this one will come below, so I can just write it says just put it as by divided by 1000. So then this 1000 and this 10 raised to minus second, which is 10 raised to 3 and 10 raised to minus 3, they will cancel each other. And finally you will get this one is minus also here. So finally you will get minus 5 cos 1000 t. That is your answer. So now that is the output of this circuit. Okay. So this question they can change the value of 1000 into something else, or they will give you in omega t, sine omega t, and they will give omega frequency, or they will give f, and then you have to calculate what is omega, you have to multiply it with 2. So such changes can happen in this kind of problems. Also, they also ask with diagrams. So in this case, if you consider the input voltage, for example, I will just draw that. So this is the axis, voltage axis, and in the given problem they have given 5 sine 1000 t. So I'll just draw that. So this is your x-axis, and this, let's say this is time, and we are having 5 sine 1000 t. Okay, so let's consider a sine wave. And this is maximum voltage is 5, it is 5 sine 1000 t. So when t equal to 0, you get minimum, that is 0, and with respect to the value of time, the sine wave will be changed. Now if you plot the result, your result with in this graph, then which means output, okay, output voltage is nothing but minus 5 cos 1000 t, cos 1000 t. So in that case, how will be the output voltage in this particular case? So the if you plot that, then you can see from here that it is minus 5 cos 1000 t, and this 1000 is constant, or it is same for both input and output. So it will just multiply with the t. So as you can see this, for example, if you consider sine, if you are considering sine of t, then when t is equal to 0, we will get this value is equal to 0, t equal to 90. If you are considering that angle, then that is equal to maximum. Okay, sine maximum and t equal to 90. If you are considering in degrees, or if you are considering in radians, it will be different. Okay, so that is pi by 2 value. Okay, then if you consider again some different value for t, let's say 180 pi, then in that case you will be getting again 0 and so on. Okay? So that is how the sine graph works. So if you are multiplying any factor here, for example 1000 or something, then your value will be that graph will be shifted in x axis. So when you are getting maximum, or if you are getting maximum for t equal to pi by 2 value, okay, then you have to you are multiplying this with 1000. Okay, so then it will be a large value. So when you are getting pi by 2, then within that very small time interval t, which means t into when t into 1000 equal to pi by 2, you will get that maximum. Okay, t into 1000 is equal to pi by 2, you will get maximum. So that is not a problem here. We just have to plot this graph in general. So this is 5. That is magnitude of that sine that is given in the problem. That is input. So this is your input curve. Now I have to plot the output. Output, you can see this is minus 5 times cos 1000 t. Okay, minus 5 times cos 1000 t. So minus 5 means it is starting in the other portion. As you can see here, it is minus 5. Let's say this is minus 5. And it is not a sine wave, it is a cosine wave, which means at this point is 1000 into pi by 2. this value. Okay, this point is 1000 into pi by 2 in x-axis. So when t is equal to pi by 2, okay, when t is equal to, or t will be some different value. Okay, so this is I think yes, 1000 into t is equal to pi by 2. That is this problem. Okay, so okay, I have to, then in that case I have to write this is 1000 t. Okay, 1000 times t. If you are writing this as 1000 times t in your axis, then this will be your pi by 2. 1000 times t is equal to pi by 2 is this point. Then you can have this kind of graph. If you are considering it this as pi by 2, okay. So then okay, then you can draw this from here. It is starting. Okay. So it is a cosine form. Okay, cosine means it is starting. It is maximum will be at 0, and it is in. It is having a minus sign here, so it is starting from the negative potential or minus 5. Maximum value is minus 5. Then it is going to the plus 5 portion. When this is 0, it will be at maximum, and then it comes back, and it will become 0 when this point, and it will be maximum again at this point, which means minus 5. In the minus direction, it will be maximum, and so on. Okay. So this is how the plot will be different. So sometimes they will also ask what will be the output of or output waveform for this particular input. Okay. Then you have to consider what will be the output voltage first, and what will be the form correspondingly. For example, if you are having a triangular wave, as you can see, as you know this equation, or triangular, or you can consider square wave. This is the simplest case. If you are considering a square wave like this, then you can see for a square wave you are having, if you are considering this as your high volt, let's say plus 5, and this is 0, then for this constant region, if you are doing integration, you will get a straight line. Okay, and again this constant region, if you are doing your integration, then you'll get another straight line. So for all those constant region, we'll be getting different kind of waveform, or it is just a straight line. Okay, so if you are considering in this case, if you are integrating this one, then plus 5, if you are integrating, what will you, so let's say this is your input, V input. So when V in is equal to plus 5, so if you integrate this one with all those constants and everything, 1 by RC into integral of plus 5 dt, okay, and then you will get 1 by RC times 5t here. Okay. So in that case, you will be getting a straight line with multiplication of this factor also. Let's assume this is equal to 1 for the uh, convenience. Okay, 1 by RC is equal to 1. Then you will get 5t. So this is equation for a straight line. 5t is, it is like y equal to mx plus c. So your output voltage will be always straight line equation, and in this case it is 5t means your m value is positive. M value is positive, and in that case you will be getting a positive slope for this case. But I think I have one minus also here, right? Minus 1 by RC into 5 dt. So this will become total. It is going to become, if you are considering 1 by RC is equal to, if you are considering 1 by RC equal to 1, then V out will be equal to minus 5t. Okay, and in our case, this is going to be so in y equal to, it is like y equal to mx plus c form. So your slope is now minus 5, or the slope is negative with respect to t. Sorry, variation is in t and slope is minus 5. So you'll be getting a wave which is a straight line, but which is decreasing from its maximum value. That is what you'll be getting in this case. That is minus 5t. With respect to t, it will be decreasing. So if you consider that case, okay, so if you draw the output of this one, then you will be getting minus 5 volt, and that minus 5 volt will be decreasing each with sorry, it will be increasing with the time. Output voltage will be increasing with respect to the time. So that is just a linear increasing. So if you consider this as your when t equal to 0, that is going to be 0. Output voltage is going to be 0. And when t is equal to 1 second, if you consider, then your output voltage is going to be minus 5. Then t equal to let's say 2 seconds, then you will be getting minus 10 volt and so on. So that will be increasing in that fashion. Okay, so minus 5 is the slope of your that is change in y with respect to that change in time. Okay, just you take that, then you will be getting minus 5 for each time interval. Then your value will be decreasing. And suppose if you are having your square wave is going to minus region also, then you will be getting this side. If you are integrating, then you'll be getting an additional negative value for your output, so that the this slope will become positive. Then you will get a opposite curve. Okay, so in this case it will be like it is minus 5t, minus 5t. So that is when t equal to 0, that is going to be 0. When t equal to 1, it is going to be minus 5, and then it is minus 10 and so on. Okay, so it is uh, slope is minus, it is decreasing. And then when you consider this portion, this side, then its slope will become positive, because already there is a negative side or negative potential or negative voltage, and that you have to multiply with this. Let's say this is minus 5 volt here. The diagram is not accurate, just even explaining those things. If you consider this as minus 5, okay, then you can see minus 5 here, then minus 5 if you multiply with the minus at the output end. We are already having minus 1 by r in there, so that minus and this minus will get cancelled, and you will get 5t. Okay, so from there onwards you will be getting a positive slope. So positive slope, and it is going to be reaching at the other end, and then this continues. So basically you will get a triangular wave, but that points where it is starting, where it is ending, and what is the slope and all those things, that you have to find. Okay, and so that they will give square wave at the input, and they will ask what will be the form of output, waveform of the output. Such questions also may come in the exams. Okay, so that is another thing. Same thing if you are considering for differentiator also, you can see different waveform. If you are giving sine wave, then you have to get cosine. In the case of in the case of uh, differentiator, you have to get a cosine, and if you give cosine, then you have to get a minus sign. Okay, all those things are there. I think we have made one mistake here. For integration, I think integral of sine we have to, okay, we have to give one cosine here, right? So this sine, integral of sine is minus cosine. So this waveform again will change. Okay, so since it is minus, then this will become plus, right? Integral of sine is cosine minus cosine. So then you will get plus 5 in that case in the final output. So the, okay, I think the way should change. You just check that. So the way should again start from 5, but it is should be like this, and reaching at the maxima here, and it is going like this. I think it should go like this, right? because when you are integrating sine, you should get a cos, minus cos. When you are integrating cos, you should get a sine. Similarly, when you are differentiating cos, you will get a minus. So if you are considering scenario with the differentiator, then you will get, suppose if you are differentiating a cosine wave like this, it also depends on what they have given in your problem and all those things, input voltage, whether it is starting from negative or all those things are important. For let us consider the simplest case. If you have given a cosine wave initially, that means cosine at the input, so the input will be varying like this. Okay, that is your input, and then if you calculate what is the output after integration, if you have given cosine wave, then the integration of that will be a sine wave. Okay, integral of cosine, integral of cos some t dt, that is equal to sine t dt, sine t, integral of cos t is sine t. So in this case, there is I think integral of sine t, yes, integral of sine t is cos t. So integral of cos t, no, integral of sine t is minus cos t. Okay, so integral of cos t is minus. No, integral of cos t is plus sine t. Okay, that's right. I'm confused with this thing. So, okay, integral of cos t is sine t. Okay, that's right. So in that case, your output will be like this. Your output will be like this. Okay. Wherever you are getting minimum for cos, you will be getting maximum with sine, and wherever you are getting maximum, you will be getting minimum for maximum for cos, minimum for sine. Just so at this point you have to get maximum. Okay, at this point you have to get maximum for cosine, and it will get. So this point you have to get minimum, and so on. So that is your output, and it also depends on RC value and input value, all those things. Similarly, if you consider a square wave here and see what will be the output of the square wave, you consider a square wave like this and see what is the output for differentiator. I'm talking about differentiator now. Okay, for differentiator. So for square wave, if you are differentiating a constant, you will be getting a 0, right? If you are considering a square wave, and if you are differentiating that, then you will be getting a 0. So if you consider this as plus 5 and this is 0 and this is minus 5 voltage, okay, then in that case you will be starting from plus 5, and if you are differentiating this constant value, if you are differentiating constant, that will become 0. So it is not going to become 0 suddenly, but it is gradually approaching to 0, something like this. So it will be 0 like this, and then when you reach at this point, you will be getting the next spike like this, and it is going to become 0 like this, and for the next one, you will be having the next maximum, and then it is going to become 0. So that is how will be the differential output, after differentiation, what will be the output. So for this constant region, I am just drawing that output here. So it will not become 0 directly, because you are having a capacitor in the circuit, and it will be going slowly into 0 like this, and all these points it will be 0. Then in this portion also it will be going to 0 like this, and all these points it will be 0. Then from this maximum it will be going to 0 like this, and all other points it will be 0, retaining it 0. So that kind of wave This kind of wave will be you will be getting. But there is a problem here that when you are considering differentiator also you are having a negative sign. Minus RC for differentiator also you are having minus RC times dV out by dV dt. Okay, so this minus also will come to your output. This is dV in your output side. So this actually this waveform will be different. Okay, it is not exactly like this. I'm just doing this because you should know what are the mistake that you might also do in your exams. Okay. So in this case, then you have to consider that minus sign. So when you consider that minus sign, the wave will be different. Okay, let us initially consider the same waveform, square wave with the minus 5 and 5. This period should be same. Okay. In my drawing, it is different. So let's say this is plus 5 volt and this is corresponding to minus 5 volt, minus 5 this point, and this is plus 5 volt. And when you differentiate this, you have to consider this sign also, minus RC times dV in by dt. So when dV in by dt, if you do, that is going to become 0 because this is a constant value. This is a constant value and this is also another constant. So for all those constants values, your output is going to become 0. This is another constant. So all those constants values, your output is going to become 0. But when it is going to become 0, you are also having a minus RC here, minus 1. So it is starting from here minus value. Instead of plus 5, it will be starting from minus and it is going to become 0. And for all this cycle, it will be 0. Then for negative side, it will be starting from positive value and it is going to become 0 like this. And for all other values, it will become 0. And then for the positive value again, it will be starting from here and it's going to become 0 like this. And for the next positive cycle, it will be starting from here and it's going to be 0. Okay, which means your output will be like this. So it is starting from here and becoming 0, then constant it is 0 in all those region. Then it is starting from here and it becomes 0 and then it is reaching the same point and then again it is starting from this value and reaching to 0 like this and all 0 then again like this. Okay, so this is how the waveform will be. When you consider differentiation of square wave in with this opamp, okay, differentiate. Similarly, you have to consider the differentiation of triangular wave. That is very easy because for triangular wave, it is just following this y equal to mx plus your straight line equation. So if you differentiate this one, then you will get m. But if you are differentiating a triangular wave, then you will be getting a square wave. Only thing that you have to consider is this sign, this minus sign at the outside of your equation. And after that you have to consider what are the given values, that is the maximum potential or maximum values of that triangular wave. Okay, that also you have to consider. And then you just differentiate this input voltage and you can see what is the variation. Once you know what is the waveform and what is the maximum value of the output, the slope or the RC value, then you can easily get the answer. And now we will consider another problem in this op-amp section. So we are discussing some of the problems in this section, and the remaining thing you can do by yourself. The only thing that you should know the basics or the working of the circuit, and just you have to simplify that circuit. That's all of the matter. So that another important thing that I have to discuss is if you are having a diode uh, in the uh, in the feedback section instead of a capacitor or a resistor, if you are having a diode like this, okay, a diode like this, then it will be acting as a logarithmic amplifier. Okay? This will be acting as a logarithmic amplifier. Uh, if you are having a resistor here and a diode here in feedback, or if the diode is in this section and if you are having resistor in the feedback, then it is acting as an anti-logarithmic operator. Okay, so this will give you logarithmic value. Okay, so this is nothing but logarithmic amplifier. Okay. And if your diode is placed in input part and resistor is in feedback, then you will be getting a anti-log amplifier. Or if you are also having another circuit, we are having also a circuit like this, diode here, and so this circuit will be acting as a detector. This will be acting as, this is just giving you this hints if they ask what kind of circuit or what will be the output form of this circuit and so on. So then you can answer these questions. Okay, so let us move to the next problem. And okay, okay, we will consider different kind of problem here. Voltage divider, we have already covered the voltage divider problems. Okay, we will do one problem. Let's say you have given the opamp parameters. Let's consider another problem that you have given opamp parameters as for given for an opamp. Let us consider for an opamp the open loop gain AOL. This is equal to 50,000 and input impedance Z in, that is, this is for op-amp, this is 4 mega ohm, and Z output is equal to 50 ohm. All these are parameters of the op-amp. Now the value of input impedance, we have to find out what is the value of input impedance, output impedance, and closed loop gain. What is the value of, we have to find out what is the input impedance, output impedance, output impedance, uh, and closed loop gain. Okay, closed open loop gain is given. You have to find out what is the closed loop gain, and the circuit is have input resistor then given to minus terminal. Then we have that feedback connection. Circuit is simple. This is output, and plus terminal is grounded, and this side. This is a circuit. The only thing that you have to calculate is what is the input impedance of the circuit, output impedance of the circuit, and closed loop gain of the circuit. And in this case, the given values are open loop gain of the op-amp, input impedance of the op-amp, and output impedance of the op-amp. So what we have to kind of find out, input impedance of the circuit, output impedance of the circuit, and closed loop gain. Okay, these problems, these kind of problems are direct problems. For this, you have to remember what are the equations related to input impedance, output impedance, and closed loop gain, all those things. Okay. Once you know that equation, then it is very easy to calculate. Okay. So input impedance is nothing but input impedance in this case of the circuit is nothing but Ri, and that is equal to R1. Okay, so in this case you can write this as input resistance or R1 or Ri, all those things are same. Okay, so that is equal to okay, I didn't give the values. Values are also given in the circuit 1K, and this is 100K. So this is nothing but 1K. 1K is the input impedance, 1 kilo, which is approx, okay, almost equal to that. This input impedance is almost equal to this one. And the second one is the feedback, output impedance. You have to calculate what is the output impedance. And the output impedance equation for output impedance of the circuit, Z out will be equal to, this will be Z out of the opamp. I will just put it as, I think Z out I have given there. So we will put this as ZO, output impedance, ZO. And this is equal to Z out, that is output impedance of the op-amp divided by 1 plus open loop gain times feedback factor B, feedback factor. Now how we'll calculate feedback factor? Feedback factor B equal to, feedback factor B equal to, this you know what is the equation for this. This is Ri input resistance by Ri plus Rf. Okay. This Ri is equal to R1 in our previous case. Okay. Previous problems. Now what is this value? This value is nothing but Ri is, I'll just write it here. Ri is nothing but, this is equal to, Ri is nothing but 1K, so 1 by 1 plus 100, right? So this is almost 0.001 value. Now you know what is B, and open loop gain is given already, it is there in problem. So if you know what is B and open loop gain, then you can calculate what is it out or output impedance of the circuit, that is equal to output impedance of the op amp is given, that is 50 ohm. So 50 divided by 1 plus open loop gain is 50,000, and then multiplied with 0.001, that is feedback factor. And if you calculate this one, then you will be getting output impedance of the circuit, that is equal to 980 milliohm, 980 milliohm. Okay. Now similarly, you have to calculate what is the closed loop gain. Closed loop gain is very easy because the given configuration is inverting configuration, as you can see from here. Input is given at this terminal because the other terminal is grounded. Okay, so this terminal we will be giving that input voltage. So the given configuration is inverting configuration. So for inverting configuration, gain is equal to closed loop gain. We are talking about closed loop gain. Closed loop gain is equal to minus Rf by R. Closed loop gain is nothing but when you are having that feedback resistor, or when you are having this feedback connection, then it will become a closed loop. then the gain corresponding to that case is called as closed loop gain. If there is no feedback connection, then it is open loop gain. Then a closed loop is minus RF by R for inverting configuration, and that is nothing but 100 divided by 1k, and that is nothing but 100. So the gain is 100, closed loop gain is 100. So this is minus 100, not 100, it is minus 100, minus RF by R. So this is minus 100 by 1. So minus 100 is the gain, which means that the output will be 100 times more than the input with a phase shift of 180 degree. Okay, that is meaning. So that is minus 100 is the gain, closed loop gain. So this kind of direct problems also may ask in the examination. So in that case, we should know what is the respective relations or equations to find out these kind of parameters. Okay, so let us stop here, and we will discuss some more problems from other sections from DAC, digital to analog converter, and some other miscellaneous problems from amplifier section, transistor amplifiers, or in case of diode circuits and all those things. There are some questions, few questions that are important that might come in exams. That also we will discuss in the next.